Hello everyone, my name is Ashutosh Singh and I welcome you all on EXNODS. I have organized two workshops on algebra coding theory and delivered lectures on Magma and SAYS math. So after getting feedbacks and many requests, I am making one playlist here at YouTube. The playlist name will be like Magma, and I will include each and everything. For example, here I will include basic things like syntax and all, and then I will discuss about group theory, ring theory, field theory, linear algebra, and then coding theory. Okay, so this much we will cover here, and in any language we need, for example, in it is Magma, but if you have whether you have R language, C language, Python, or says math, or any language you have. So in all those languages you need, like you write in different way, you write the program in different way, and then you have to run those programs. You need platform. So by the way, this Magma is a paid software. You have to pay something, and then you will get the access, offline access. For online, there is one calculator, but you have to search online Magma calculator. For example, if you search only Magma, then it will be something like this. Then it will be something like this. So even I'm using frequently, then also I'm getting like this. Okay, so what you have to do, you have to search Magma calculator. So calculator, it is okay. So if you search Magma calculator, you will by default you will get the site, and then here you will get all the things. For example, this is documentation. Okay, so here you will get all the things what Magma includes. For example, this is Magma language, then set sequence and mappings, and then you have rings, matrices, and linear algebra. Then other like fields, modules, and all other things are there. Algebraic geometry, arithmetic geometry, and here's also we have topology, geometry, combinatorics, coding theory, cryptography, and optimization. So this much details, this much things we can do, this much computation we can do in Magma. So but if you have to compile the program, for example, you have something print just first program. Okay, so you have to write like this, hello, and then you have to submit. You will get output here in the second box. Okay, so this box is for your program, and this second box is for output. Okay, so if I just refresh this, so you will see this like calculator calculations are restricted to 120 seconds. Okay, so there are some limitation uh, in this online calculator, but majority of the time you will be able to, if your program is smaller, you will be able to compile the program. Now, starting with this, so this is the link for that calculator, and then we need next what we need comment, how to write comments. So it is very similar to C language. You have to, for if it is one liner, then what you have to do, you just write this much, and then this will be considered as a comment. And for multi-line, you can use this one. And if there are so many, your line is a little bit lengthy, and you need to adjust into two or more lines, then you have to use this for backslash for line continuation. Okay, sorry. So this now we need assignment, like we need how to write variables, because in mathematics we need x is equal to what we have, like what variables we have, right? Most of the time we need variable. Whenever you have any polynomial, you want to find out the roots or factors or anything, you need variables. Okay, so how to write the variables, what are the permissible, because if you know any language, by the way, you can by the way, if you know any language like C, Python, or language or any other language you have, you are known to, then you can easily relate to this language, and you can easily find out the analogy between these two things. For example, here I'm using C language. This is similar to C language, but yeah, if you are not aware of any language, totally fine. You can go through this video, you can go through the content documentation, and you will be able to find out each and everything. Okay, so here I'm using like for this particular section, I'm just giving you the analogy. For example, in C language, you just need just equality sign. Okay, in R language, you need something like this. Okay, in Python also just equality. Okay, but here you need something like this to assign the variable. Okay, so it is like assignment. Declaration is you don't need anything, because in C language you need int, float, or something like this, right? But here you don't need anything. You just write x is equal to this. It will automatically assign it to that particular database. Okay, so here we have variable, then we have expression. You can put the expression. So it is defined like this. Assignment is defined like this. Suppose you have many parameters. For example, you have a ring, or any finite field you are using, extension of that finite field you are using, or polynomial ring in two or more than two variables. Okay, so you can use this notation to define the domain. Okay, to define the that algebraic structure. Now, this is also one way of assignment. It is very common in other languages also. For example, you are writing x and then operation name. For example, x plus equal to 1. So it is also common in C language. So just if you're writing this, this means what? This means x is equal to x plus 1. X is assigned to x plus 1. Okay, for example, earlier it is x is equal to 5. Okay, now it will be x is equal to 6, because it will add 1 to x and then it will assign here. Okay, so it is like if I'm writing x operation op, some expression maybe. Okay, this the meaning is like x equal to x operation, that operation plus multiplication, anything, division, and then that expression. So this is the meaning. Okay, so if it is like plus, then it will be plus and that expression, whatever expression, or you have a single value, it is up to you are up to your program. Okay, so this way we can define. This is also similar to the second one. So here also we can define like this. Now, definition is okay, like assignment is okay, but how to write identifier? We call this type of variable as assignment, or okay, we identifier our variable names. Okay, so how to write? For example, in we are known to this, that sometimes it is very difficult to find out or write in particular format. For example, you have a special keyword. Okay, so you cannot use that as a variable name. Okay, so similarly in Magma also we have like identifiers are name for user variable. Okay, fine, function. So we call this name of variable or function, etc., as identifiers. Okay, now here restriction is this: they must begin with a letter. After the first letter, they can contain any combination of letters or digit. So letters or digit they can contain. Okay, and the name must not be reserved word. Okay, so this should not be the case. Now you can find out the list easily, that what are the reserved words. So you don't have to. By the way, after some times you will be able to know what are the, I mean, what combinations we can take. Okay, they are a very less reserved word. Now this underscore is treated as a letter. You can combine it here, but single underscore is a reserved word. Okay, I will tell you with the example also, that how we are using underscore as a variable name or something like this. Okay, then identifiers are case sensitive. For example, if I'm writing a is equal to 5 and capital A is equal to 6, so these two are the different thing. Okay, or even 5 also. So these two are the different variable name. You can use small a also, capital A also. Okay, then Usually in Magma, for example, sometimes if you, for example, you are studying Mathematica, MATLAB, or maybe Says Math or Magma or something like this. So you have same thing. Like for example, you are finding the GCD. What is the GCD? So in different language, for example, it is written like GCD, but here it is written like this, GCD. Okay. Or maybe you are writing print also. You are writing any other functions. Okay. For example, you are writing phi. Okay. In some, it will be like something like this. So this way, things are differentiated. And here, Magma functions usually starts with capital letter. Okay. Even if you are using like integer ring, for example. So it will be like integer ring. Okay, so first letter of this will be capital. It is something like this. Okay, but in other language, it is like all the small or all in the capital. Not all in the capital, but majority of the time, it is like all in the small. Okay, so this way we have some exception also, like p code, p quotient, and these are the exception, some exceptions. So this is like how we can use identifier names. Okay. Now, starting with some examples, like suppose we have s is equal to this list we have. Okay, so first value is this one, second value is this one, third value is this one. By the way, starting is like here, starting is like 1 2 3, not 0 1 2. Okay, it is like if I write what is the value of s0, so it will give, I mean, error. Okay, why? Because 0 is no place, or it starts with 1 only. Okay, and then 1 2 3 so on. So s is equal to, if we print this, this will be the output. And if suppose I want to access this one, or I want to change the value, for example, here what is the output? This will be the output. Okay, if I'm changing this s22 means it will go to second place, and in the second one it will go for this place. Okay, so it will give the value, it will assign it to -1. Okay, now if you print this value, you, by the way, you don't have to write print. You just you can use this also. You can directly write s and it will print the value. There is no problem. Okay, so you can avoid this this type of calling. Okay, so here if you print this value, it will be like 1 2 -1 4 5 6. Okay, something like this. So if I have to write compile this program, so by the way, you can compile this easily. For example, I'm writing here x is equal to, and this is like 1, this is, I'm just giving you the two values only. Other things you can easily check. So it is like if I print this value, this will be like 1 1 2, and suppose I am writing this as 1 comma, or maybe 2 comma 2, and if I'm writing it like -1, so after this, if I'm printing this value as, so it will be like, in place of 2, it will be like -1. Okay, so this way we can change the value. By the way, when I will start this, I will again give you examples and all. So see, syntax is like majority of the commands you don't know. So don't worry, because you don't know what is this, why. If you are familiar with some language, then it is okay. Like why I'm writing this, why I'm changing like this, because this is not clear. This is like list. I have to take that class, that lecture also. Okay. For example, this GCD, it is not clear to you. I'm just giving you example how you can assign the things, how you can take the name, or how you can identify the identifiers. Okay, so here it is like if we have GCD, if you want to write GCD, you can write GCD easily, GCD. But if you want to write XGCD, for example, t is equal to ax plus by, and you want to GCD of a and b, so it will also give the value of x and y. Okay, you can get the value of x and y such that d is equal to x plus by. Okay, so it is like from here you will get three values. Okay, so three values will be, first will be d, second will be x, third will be y. X is corresponding to 12, y is corresponding to 15. Okay, so it will be like if you are giving only two values, so it will print d and x. It will ignore the y part. Okay, but suppose you want d and y, you don't want x. But here either you have to print 3 or you have to print dx or d or dxy. There's no option like this d and y. So in that case you have to write this underscore. So it will not print, it will not assign the value of x, it will give only d and y. Suppose you don't want this value d, so you have to use this. Otherwise it will give, for example, you are writing only this much, x comma y is equal to x gcd of 12 and 15. So it will return d here, x here, and y will be ignored. Okay, because it will treat x as a d gcd and y as a x, and y it will ignore. Okay, so you have to be very careful with the with this type of notation. Okay, now suppose now it is assigned, it is like stored, some d has some value, or so after d and x has some value, so after sometimes you don't need this much space to be allotted. So what you need, what you have to do, you just uh, put delete x. For example, you want to delete x space, x has some space, y has some space, d has some space, but you don't want this value. Okay, so what you can do, you just write this delete x and it will delete the variable. So let me give you this direct example. For example, I'm writing delete s, and after this I'm printing this s value. So now it is giving the error. Why error? S has not been declared or assigned because I have deleted this variable s. Okay, so sometimes it is very effective. It is necessary also because I'm using, for example, I'm using local variable, global variable, something like that. So we need this type of command also. Okay, now I hope this is clear. This variable part, this is clear. Now let's go to some structure. Okay, for example, we have Boolean structure. We can avoid this thing, but majority of the time if I'm discussing if and only if condition or anything, so we need this type of thing. Okay, so what we can do here, Boolean structure we define like this: Boolean parenthesis. Okay, parenthesis open and close. Now this Boolean has to be like, first letter has to be capital, and then this will be like a Boolean structure. So how many variables in this? Just two. What are those? True and false. These two values will be there. Okay, if you put the cardinality sign, by the way, this is the cardinality. If you put has b, it will give the cardinality of b. Okay, now it will return the number 2. Okay, now it has two values only, true and false. Now if you put this function name random b, so it will give the random number, like a random element, like sometimes true, sometimes false. We have two possibilities, so it will be like either true or false. Okay, so this way it will give the random value. Now if we have x and y, I hope and this is clear, very much clear, like this is Boolean operator. So we have and, or, XOR, not. So not is, by the way, unary operation. Unary, these three are binary operation. So we have, for example, x and y. X, y belongs to Booleans. So this is like if it is like true and true, then it will be true. Otherwise, it will be false. Okay, here if it is like false only, then only it will be false. Otherwise, it will be true. Okay, here x or y. In mathematical, we write like this. So it is like 1 or 2, but not both. If it is like true, true, so it will give the false. If it is like false, false, it will give the false. For other two cases, it will be like true. Okay, so not X means if it is true, then it will give false. If it is false, then it will give true. Okay, so these type of Boolean operators and these things we need again and again when we are going for when we have to do some program with conditional statement or with the looping also we need conditional statement. So in all these cases we need Boolean operator as well as these type of like variables. Okay, so that's why I've given here. Okay, now then we have not equal to and not equal to also. For example, if x is equal to y, x is equal to 5, y is equal to 5, then it will give the true. Okay, any random thing. For example, x is equal to true, y is equal to true. So here for all these cases, you need a Boolean element. X is equal to true or false. It has two cases. Okay, here it can be anything. These x and y can be anything. Okay, it is not necessary that it has to be true or false. Okay, so it can be anything. For example, x is equal to 5 equal to 4. If I'm writing 5 eq 4, so it will give the false. Okay, and similar thing with the not equal to. Not equal to means any means not equal to. Okay, so this way we write the things. And suppose we have a here we have example. So I want you to perform this program. By the way, let me tell you only one thing, like it is not we cannot copy here, so let me just write it here in this okay, so like with the phrase like suppose we have z is equal to, or z is used for something like this, I mean integer range. So let me write a is equal to Boolean. I told you like we need, if we have Boolean, so it has to be capital first and then a is equal to something like this. Now we want something like whether x suppose x and y are the random thing. Okay, so x x comma y in, or suppose I'm just writing x is equal to 5 and y is equal to 6, so it will be like x equal y. What is this value? So it is like okay, it is Booleans. Okay, so it is like false. Okay, if I am writing here 6 also, so it will be like true. Okay, and if I write ne, because these two are equal, so if I write ne, it will be like false. Okay, so this way we can see the differences. And why I didn't use this for loop, because again I have to give these type of example again and again. Okay, now what about this? There are a few more commands like CMP EQ means comparable. Okay, so CMP is like comparable. So this is like suppose our data set is like something like this, 1 EQX. So here it is like integer, it is a string character. So these two are different data set. So it will give error, but here it will give false. Why false? Because it will like consider this as element. It will not see the different thing. It will consider like whether it is are equal or not. Okay, so for that cases we use this type of thing. But I want you to, or majority of the time we use this type of things, because we want error. If there is any error, or then there is any there is no similarity with the domain or algebraic structure, we want some error so that we can ignore the part. Okay, so that's why I stick with the EQ, not CMP EQ. Okay, now one of the most fascinating and interesting thing in Magma is coercion, and very frustrating also. Okay, so it is like suppose we have some domain, something we have, and we want coercion of this thing. Okay, we want to see whether it is coercible to that domain or not. This is like a Boolean element. Whenever we write is, so even sometimes I don't know the command. So what I do, I write just is. If I want something like Boolean answer, true or false, or something like whether this is principal ideal domain or not, whether this is a PID, I mean PID or not, whether this is a UFT or not, or something like that. So what I do, I just have to queries things. So let me give you one example. For example, we have finite field. Finite field is defined like this. I will tell you again how to do this. So I'm writing T like a primitive element. Okay. So and suppose Z is equal to integer ring. Z is equal to integer ring, something like that. Integer ring. It is defined like this. If I want Z is quersable or not, if I want to coerce T to Z, it will give definitely give the error. Okay. So let me write it here also. Okay, here we have Boolean. So let me do this with Boolean. So let me write A, and let's check whether this is quersable to A or not. So no, it is not illegal coercion. Okay, why? Because this is Boolean. This is an integer ring element. Okay, so this way we have seen that these two are the not this X is not coercible to Boolean, because we know that in Boolean we have only two element, true and false. So how can you associate 6 to true or false? But sometimes, for example, you have polynomial ring. Okay, you have polynomial ring over this field. Okay, and in that polynomial ring, you want to coerce element of these things into that polynomial ring, or with some other polynomial ring you want to associate the same thing. So we use this type of coercion. Okay, and sometimes it is very much required. Okay, and so we have also time command. For example, you have a statement, you want to check this time, what is the CPU time and all. So you can use these commands. You can find out the types of variable or category using these commands. Okay, so this is one example I have given, and second one is like Boolean one. So this is all for today, for this lecture.